The purpose of the experiment was to test the effect of 7 different temperatures on the rate of carbon dioxide production in yeast by measuring the fermentation rate. If the temperature of the reaction is increased, the rate of fermentation will also increase. But if the reaction happens at a high temperature, usually around 60 degrees, the yeast enzymes will denature and the fermentation will not happen. The reaction will not happen if the temperature is too low either.
While the procedure of the control involved measuring the volume of CO2 produced at room temperature, our procedure measured the volume of CO2 produced at 10, 15, 37, 45, and 50 degrees Celsius. The incubation of yeast suspension was first done at the desired temperature for 5 minutes. To increase or decrease the temperature of the reaction, the setup for the yeast fermentation experiment was placed in either a cold water bath or a warm water bath at the desired temperature. In fact, only the pipette was submerged in water for each experiment. The measured volumes of CO2 produced by the yeast fermentation experiment were graphed as a function of time for each of the chosen temperatures. Multiple trials were done for each temperature, but an average volume of CO2 was calculated and graphed at each temperature. A trend line was then made using only the linear part of each resulting graph, and the slope was calculated to measure the rate of respiration. A final graph was made which compiled the calculated rates of fermentation at various temperatures to demonstrate the relationship between an increase in temperature and the rate of respiration. In conclusion, when the temperature at which the yeast fermentation happens is increased, the rate of the reaction also increases. In other words, more ethanol can be produced in a shorter amount of time. Increasing the temperature of the reaction in industry would offer greater yields of ethanol in the same amount of time, and therefore would maximize the production of leavened bread, beer, and other industrial products that require yeast fermentation. Of the various temperatures at which fermentations were conducted in our experimental procedure, the optimal temperature for industrial applications of fermentation, such as the production of biofuels, would be around 50 degrees Celsius. In fact, the rate of the reaction was fastest at such a temperature.
And I will do it for you.